So today I'm going to mostly focus on just making the basis of a drivetrain, a sheet metal drivetrain. I'm not going to focus mainly. I'm not going to focus on on making a gearbox today, a custom gearbox. We're just going to work with an off-the-shelf gearbox when we get to that point, just to make everything run a little bit quicker. Something else I wanted to point out is from long-term standpoint, not really focusing on your projects right now. There's some talk about switching to a West Coast drive over sheet metal, which might end up being the actual thing that happens, just because West Coast drive is much quicker to design and much quicker to put together. So when we actually go to we can start the season much quicker on a building standpoint if we're using West Coast drive than having to wait for one sheet metal order to come in. So yeah. And then, so right now, what the drivetrain size I'm thinking just to make in reference is a 30-inch width by 28-inch 30-inch length and 28-inch width. So first thing I'm going to start off with is the rails. So let's make this 30 inches. I'm going to be making a 1/8 inch center drop. Just as a reminder for anybody watching this later on who doesn't know what a center drop is, it's basically a you need it so that you don't get too much traction on the floor while turning. So it makes it a lot smoother when you turn, since you have less contact with the floor. And usually it's within anywhere from a 1/16 of an inch to 1/4 of an inch. But most times you'll end up seeing that it's like 1/8 of an inch. And then we do our wheel sizes, which for this I'm just going to be using a 4-inch Coulson. Then from here to here. This line I just made will end up being the line that we actually measure with, because when we're making a chain or belt system for your drivetrain, you just need that line to make sure that you're actually within the center distance allowed by the center calculators for either chain or belt. So I'm going to be going over the center distance for chain first. Okay. So the pitch for so the pitch for 35 chain is 0.375. This is all the numbers for the different types of chains. in FRC, we mainly use number 25 or number 35. So you really don't have to focus on the other ones because they're going to be way too heavy for anything on a robot. So for drivetrain, normally we use 375, just because we haven't found perfect tension and all that for our systems like other teams like Cheesy Poos or 179 have done. So it's a little bit more difficult for us to do it using 25 chain. So normally we'll play around with a 12-tooth sprocket or 15th, depending what's inside the shop. And then you just want to do, because right now our center distance would be, we can do 12.5, 12, which is perfect because links, we want it to be on the even side. So we can do 12 exactly. And then, because the left and right side of our drivetrain are exactly the same, we can just mirror the circle about the center line. And then make this construction geometry. And then we can basically go in and let me just delete the relations here. So we can make this portion here. Let me make a line tangent to the circle. So this is how I personally do my lift from knowing my clearance height between my rails and the ground. Normally I either do this to 1/4 inch, 1/2 inch, depending on what's that year's game asking for. So for everybody doing their own personal designs right now for their seasons, they just have to go through their rule book and see what obstacles they have that year and see what's going to be the required height for their year. I know
So
this
like
year.
the game hole, for stronghold, for instance, it would be a lot higher, right? Or it's just
Yeah.
the wheels is gonna change the height.
Yes. The wheels would change your height, and your clearance height is gonna be much higher.
Mm-hmm.
Um, and what most teams did that year was they used 6-inch pneumatic wheels, or no, not even. They used 8-inch pneumatic wheels. Because I don't even think West Coast Products had came out with the 6-inch ones yet. So I know we did 8-inch Harbor Freight wheels with custom hubs that year. So, but yeah, it's really going to be dependent on what's happening that year. This year for first, no, not first power up. Infinite recharge. There we go. I think we did an inch and a half, inch and a quarter, because the bars in the center for climb was an inch and an
Yeah,
eighth, I think.
I think somewhere there.
So let's say we were to do this at an inch and a quarter. Now most of the wheel is taken up, but we can do, let's just keep it at the 0.5. Personally, when we have these, what I like to do is we can just make this construction, where is it? Just because I don't like to have my wheels popping out on the top, just because we have braces and all that when we're doing the drivetrain. So what I'll end up doing is just going slightly above the wheels. and then doing the same tangent line trick from before to get our height, our clearance height. And then this again, we can just do 0.5 like we had on the bottom. And then, so that's how you would do the center distance for chain, make a basic sketch for the drive rail. I just want to go over real quickly how to do the center to center distance using a belt. Which hopefully West Coast Products comes up. Yep, West Coast Products. So for this one, we can use a 5mm belt calculator because normally the Vex Pro belts are, let me see, even though they say 9mm width, they tend to be a 5mm G2. Yeah, HTD 5mm. So we can do, because we just want a 1-to-1 ratio because our gearbox isn't be giving our output ratio. So your pulley number 1 would have 24 teeth, pulley number 2 would have 24 teeth, or whatever else we have in the shop. I really wouldn't go smaller than a 20-tooth pulley. And then let's put this to 12. And then smaller belt would give us a 11.4173, and the larger belt would give us a 12.4016. So in here, to change that, or to make that equivalent to what the belts give us, we would just either see which number works better for us. So like 12.4016, that works perfect for us. So we can run 24 tooth pulleys with a 12.4 center to center distance. And it's very important to do this calculation for everything on the robot, be it chain or belt, because otherwise you're going to end up getting a lot of slack, and then that just is horrible to work with. And the vice versa, it might just be too tight, and then you can't even fix it. Because at least if there's slack, you can do tricks of like putting a zip tie to close it up, or adding a tensioner like we did for this year with the drivetrain. We put a tensioning gear in. So there's tricks to solve when there's slack, but it's very difficult to solve when there's not enough space for the chain or belt to actually be put on. So I'm just gonna.
It's well, usually for belts you can't. It has to be perfect because like belts you can't fix that or like tension it. It has
Well,
to be like perfect, or it's like
belts you can tension. You just need to use a lot of teams that tension it. What they do is they just use zip ties. They use zip ties to put it together, or you just put a roller on the outside portion of it. So you would just like separate it apart slightly, and then just put rollers to keep it on the outside. Or you can put a dead pulley that basically moves freely,
in the
but
middle.
keeps them. Yeah,
Oh, just like what we put for the sprockets. I mean, for the chain this year, like it's kind of it has no function except for like just it rolls between those chains.
yep, exactly.
Yeah.
And that same thing exists for the what's it called? The drive for belts. But I'm gonna just keep this at 12 just to make this look a little bit nicer. Also, I'm going to do the tandem trick on the left so that we have a nice clearance space here. Actually, also, this 30-inch, if we want the actual length to be 30 inches, we have to remember the thickness of the belly pan, which we tend to do, if I'm not mistaken, 1/8 inch belly pan. I want to say 8 inch or 90 thou. Times 2. Okay, so this should have the same gap between here and here as over here. I just like to make sure of that because you like to, whenever you design anything, things have to be symmetric as mostly as possible, just because it decreases the amount of parts that actually need to, the amount of different parts that need to be manufactured, which is really good because that decreases the amount of time it takes us to make drawings for parts. It decreases the amount of time of manufacturing and decreases the overall cost of manufacturing. Okay, so then let's just put in, actually, let's just do the belt one, because then I don't have to worry about tensioning right now. 12.4016. Perfect. Okay. So let's, oh, I forgot the bearings. Did it sketch? Bearings. Okay. So let's just make all 3 of these holes equal to each other. So that's much quicker when we're dimensioning. Equal, and then smart dimension, and then a bearing block is 1.25. That's the hole size for it. You can go slightly bigger, slightly smaller. Right now we just go 1.125 because we don't have a harbor press, an arbor press. If we had an arbor press, you would go slightly smaller, because right now what ends up happening is that because of tolerances, the bearings actually end up being loose inside the bearing hole, and you don't want them to be too loose. You want them to be a little tight in there. But for now, just leave it at the 1.125 that we've been using. And then we go over to sheet metal. We make not base, sorry. We first extrude. There we go. Why is it saying that it's not connected? Is it saying it's not connected? No. Okay. Good. All right. So let's make this 1/8 inch aluminum. Yep. So that looks good. So that's how you would make a drive rail.